Good morning, everyone. Happy Wednesday. We are in the middle of our week here in week 4, and we are doing great. We are pushing through. Now, before we go over pages 4 and 5 for today of your 1 through 16 end of year assessment review, we are going to watch a number rock video on multiplying by threes. Now, I know we watch multiplication division videos a lot. Remember, it's always important for us to refresh our memory. I'm always trying to make sure you're on top of your multiplication division because it's so huge in 3rd grade, because not only are you learning your facts and mastering them, but you are also using them to apply them to word problems, as you already know. Okay, so we're gonna start with that, and then we're gonna get into page 4 and 5, and then we're gonna wrap it up.
When we skip count by 4, we dance a 4 into the floor.
1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. 4 times 4 is 16. 5 times 4 is 20. 6 times 4 is 24. 7 times 4 is 28. 8 times 4 is 32. 9 times 4 is 36. 10 times 4 is 40. 11 times 4 is 44. 12 times 4 is 48.
When we skip count by 4, we dance a 4 into the floor.
4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. Do not hesitate when the beat drops. Dance before it's too late.
When we skip count by 4, we dance a 4 into the floor. When we skip count by 4, we dance a 4 into the floor.
1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. 4 times 4 is 16. 5 times 4 is 20. 6 times 4 is 24. 7 times 4 is 28. 8 times 4 is 32. 9 times 4 is 36. 10 times 4 is 40. 11 times 4 is 44. 12 times 4 is 48.
When we skip count by 4, we dance a 4 into the floor.
4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. Do not hesitate when the beat drops. Dance before it's too late.
When we skip count by 4, we dance a 4 into the floor. When we skip count by 4, we dance a 4 into the floor.
1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. 4 times 4 is 16. 5 times 4 is 20. 6 times 4 is 24. 7 times 4 is 28. 8 times 4 is 32. 9 times 4 is 36. 10 times 4 is 40. 11 times 4 is 44. 12 times 4 is 48.
When we skip count by 4, we dance a 4 into the floor.
1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. 4 times 4 is 16. 5 times 4 is 20. 6 times 4 is 24. 7 times 4 is 28. 8 times 4 is 32. 9 times 4 is 36. 10 times 4 is 40. 11 times 4 is 44. 12 times 4 is 48.
When we skip count by 4, we dance a 4 into the floor. When we skip count by 4, we dance a 4 into the floor. When we skip count by 4, we dance a 4 into the floor. When we skip count by 4, we dance a 4 into the floor.
4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. Do not hesitate when the beat drops. Dance before it's too late. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. Do not hesitate when the beat drops. Dance before it's too late.
Visit numberrock.com for exclusive content, lesson material.
All right, I hope hope you guys enjoyed that video. Now, before we get into things, remember this is the 1 through 16 end of year review, and you should be on page 4 and 5 with me for today. If not, you may need to go back and make sure you have all the other pages finished as we've gone over them already. Okay, number 17, it says Mavis is making a tile pattern in the shape of a square. One side is 8 inches across. Write the area of the tile pattern. Okay, so I'm going to flip my camera so you can see. All right, so number 17, if it says one side is 8 inches across, okay, I have one side that is 8 inches. Remember that trick with the squares. So all sides are the same on a square. So if this side is 8, then this side is 8. And if that side is 8, then this side is 8. That means all sides on the square are the same, okay? Now it says write the area of the tile pattern. Remember, area is simply length times width. So we're gonna do 8 times 8 equals 64. Now, in the problem, they used inches, so make sure you use that in your figures as well, and your answers. All right, Mr. B forgot that, so I'm gonna add that to my square. Now I'm gonna add that to my answer because 8 times 8 equals 64 square inches. Okay. Now the reason our answer is square inches is because we're using area, and then we need to make sure we use that inches inside of our work if we're drawing a picture. Okay. All right, number 18, it says Chris has 81 pennies to stack equally in 9 piles. Which equation can help you find 81 divided by 9? Now, remember, when you don't know your multiplication or your division, then you need to think of your multiplication. When you don't know your multiplication, think of your division. So in this case, we know that there has to be 3 numbers in a fact family. And we know in this case, there are only 2 numbers given to us in this word problem. So that means there's a number missing from the fact family with these 2 numbers. So there should be 81 divided by 9 equals something else. Now, remember, can't think of division, use your multiplication. So let's take a look at our options. We have 8 times 8, which equals 64. So no, I'm not gonna use that. 9 times 7 equals 63. So no. 9 times what would equal 72? No. And then we have 9 times what would equal 81. There we go. And then that question mark that we're filling in for that we know would be 9, okay? 81 divided by 9 equals 9. 9 times 9 equals 81. Okay. So our answer is D. All right, let's go to number 19. Number 19 says, which figure is a quadrilateral? Explain how you know. Now remember, when you think of quadrilaterals, you know that quadrilaterals are figures with 4 sides, okay? So when we take a look at our options, we look at figure A, we look at figure B, C, and D, we know that it has to be, it may be a little tricky at first, but we know it has to be figure A because it is a closed shape with straight line segments and 4 sides. So it's a closed shape with straight sides, and it has 4 sides, okay? So number 19 is figure A. Number 20, it says describe the steps Marco should use when finding 772 minus 384 if he is using place value to break the problem into smaller problems. Okay, I'm gonna flip my camera here. Now, when we're breaking this problem into smaller problems, this isn't a typical question we would be asked, except on things like this with like a review. So I'm not going to stress this too much. If you did 772 minus 384 and got 388, absolutely. For those that want to know exactly what it means when they say place value to break the problem into smaller parts, this is exactly what it means. So we start with 772, and then we take away 300, we get 472. We subtract that from the 10, that's 70s. That tens place, that's 70, and we get 402. Then we have 402, and we subtract that 10, and we get 392. Then we get 392 and subtract that 4, and then get 388. Now that's a long process, as I said. I'm not gonna stress that. As long as you did 772 minus 384 and you got 388, absolutely, okay? All right, our next question, number 21, it says, Rafe, I'm gonna go with Rafe, okay, works with me, broke up a large array into 2 smaller arrays. The 2 smaller arrays show 2 times 7 and 3 times 7. What was the large array that Rafe started with? Okay, so I'm gonna flip my camera here so you can see. Now with this question, they gave us the 2 smaller arrays. They gave us the 2 times 7 and, keyword, 3 times 7, okay? And then they wanted to know what the large array was. Now here, in this specific problem, we're thinking about distributive property. Now, but first, let's make sure we put it into distributed property now that we know that it is automatically from reading it when they ask us about the large array versus the small arrays. Okay, so first we have 2 times 7. Don't forget your parentheses with distributed property. That keyword and addition, okay? And then we add that parentheses to that 3 times 7. Now we have that fully distributed property that we know of, okay? Now it's asking us, what was the large array? Remember, there's always one number that stays the same, and there's one number that's broken down into addition, okay? So all we need to do is just multiply those, add those numbers, and then multiply those numbers, okay? One number stays the same, and we see that it's the 7, okay? Because that 7 is in both problems. So the 7 is the one that stayed the same. Now, when we take a look at these two numbers, okay, we see that this was broken down into addition. So all we need to do is add those two numbers to get that original starting number, okay? So 2 plus 3 equals, or I did it wrong, 3 plus 2, 2 plus 3, okay? I did it in the wrong order with my finger, okay? That equals 5. So we have 5 times 7 for our original array, okay? All right, so Raph started with a 5 times 7 array. Now, number 22, that one I could not really read. I couldn't see it as well either. So if you couldn't see that, or if I couldn't see that, I'm sure some of you probably couldn't see that. So we're gonna skip number 22. I have an elapsed time video anyway, so we're gonna go over elapsed time at a different time specifically. So we're gonna skip number 22 right now. All right, we'll come back to elapsed time all by itself. I have a video coming soon on that specifically. Let's go to number 23. It says Barry is making a bar graph to compare how many toy cars of each color he has. He has 5 blue, 10 red, 8 green, and 6 silver cars. Which scale makes the most sense for Barry to use? Now, when we're taking a look at this, let's take a look at the information that we're given. We got 5, 10, 8, and 6. So basically, we're trying to figure out which scale, which key would be the most sense to use for a bar graph. Okay, so let's start from the bottom. Would we skip count by 20s? No, we don't want to do that because we have 5, 10, 8, and 6. So then our bar graph would actually be above what we actually have. Okay, so D is canceled out. Let's take a look at C, 10 cars. Would we skip count by 10s when we have 5, 8, and 6? No, it's probably not the most. It wouldn't make the most sense to use that for a scale. Okay, so we're going to cancel out not only D, but also C. Okay, when we take a look at each grid line equals 5 cars, are we going to skip count by 5s? I don't know, because we have 6, we have 5, we have 10, and we have 8. If we skip count by 5s, we would kind of go over and we wouldn't best represent 5, 10, 8, and 6 on the bar graph, okay? Taking a look at A, which is our answer, each grid line equals 2 cars. If we skip count by 2s, we can fit all of this information on there and it will make the most sense for Barry to use that one, okay? Next question, number 24 says, Keitlin's cross-country team ran 194 miles. Lauren's team ran 159 miles. Which equation uses rounding numbers to the nearest 10 to estimate how many more miles Keitlin's team ran? How many more miles Keitlin's team ran? Now, when we think about this, we are thinking about that 4 or more, or 5 or more, we raise the score. 4 or less, we let it rest, okay? So that rounding there. So we take a look at 194, we know that would round to 190. When we think about Lauren's team, we know that would round to 160. We're rounding to the nearest 10 here, okay? So in this case, based off what I just said, and remember that 5 or more rule and that 4 or less rule with rounding, you know that it would be B, 190 minus 160 equals 30. Number 25, it says Carmen is trying to find the fraction of the figure that is shaded. Which unit fraction represents each equal part of the figure? Now, when we're thinking about the unit fraction, and it tells us represents each equal part of the figure, we know that is 1 over something, but we need to know what the something is, that denominator is, for our fraction. So let's count all of the parts. So we have 1, 2, 3, 4, 5, 6. We have 6 as our denominator, and we know that if we're focused on one individual equal part, that would be 1 out of the 6. So our answer should be C, 1/6, okay? Next question, take a deep breath. We are at our last question here, and I know it's a lengthy word problem, but we're gonna get through it, okay? Number 26, a juggler wants to make sets of bean bags for juggling. She uses 6 panels of cloth to make each set. She buys panels of cloth in packs of 10. How many packs will she need to buy to make 5 sets of beanbags? Now, I know that's a lot of information, so we need to circle back to the word problem. That is perfectly okay. She uses 6 panels of cloth to make each set, okay? She buys panels of cloth in packs of 10, okay? How many packs will she need to buy to make 5 sets of beanbags, okay? Now with this problem, it requires us to start from the bottom and then work our way back to the top. So looking at that last part, it says make 5 sets of beanbags, okay? 5 sets of beanbags, that's our question here. Then it says, going back to the top, she uses 6 panels of cloth to make each set. So 5 times 6 is what we should have done, equals 30, okay? Then we circle back into the middle of that word problem. She buys panels of cloth in packs of 10. Okay, now we're going to divide by 10. Okay, 30 divided by 10 equals 3. So our answer should have been B, 3 packs. Okay. All right, that's all we have for today. We just finished page 4 and 5. Tomorrow we'll be going over page 6. I'll be going over some key words with you and also some strategies for test taking. So I will see you tomorrow. Have a great rest of your Wednesday. Bye.